In this problem, we're going to do multiple substitutions in order to find the antiderivative of this function. You might see a big substitution to do right at the beginning that would help you solve the whole problem in fewer steps. What I want to kind of imagine is that I'm in a situation where my goal is just to make this problem easier so that I might see more to do. So what I'm going to do to start is just say, well, I see this 2r minus 1 repeated, so maybe it would be easier if I replace that and just called it x. So I'm going to let x equal 2r minus 1. So I'll need to take a derivative, dx equals 2dr, so that I can replace that dr with a dx. So dr is equal to dx over 2. So I make that substitution. And let's see, I'm going to have a x times a cosine of the square root of 3x squared plus 6. Let's see, that dr is now a dx over 2. And on the bottom, I have the square root of 3x squared plus 6. Certainly an easier function to deal with. What I'm going to do is I'm going to imagine factoring this over 2 out front as a 1/2, and just let this say dx. All right, so now I'm dealing with this integral. And at this point, I think I see another substitution that would help. I definitely see an inside function. I'm going to let u equal 3x squared plus 6. So du is 6x dx. And so that dx, I'm going to replace in a minute as du over 6x. All right, so I still have that 1/2 from before. The dx here is going to be a du over 6x. And here I have an x times cosine of the square root of u all over the square root of u. And I've definitely made some progress in making this antiderivative, this integral, look a little easier. And so I can cancel out the x's, and I still have that over 6. I'm going to do the same thing I did last time. I'll factor it out front as and make this a 1/12. So now I have the cosine of the square root of u all over the square root of u du. And we've done 2 substitutions and have a much nicer integral to deal with now. And so now I'm going to let u equal, not u equal, I'm going to let y equal the square root of u, so u to the 1/2. Right, thinking that will make this a little easier to deal with. So let's see, dy is 1/2 u to the minus 1/2 du, which really is 1 over 2 root u. And so I can think of dy as that expression. And so when I get du by itself, it's 2 root u dy. And so that's what I'm going to replace here. So I have that 1/12. And now I would have the integral of just y, cosine of y. Still have that root u on the bottom. But I know I'm replacing the du with 2 root u dy. Nicely enough, those root u's cancel. Now you might ask yourself, why didn't I call that y? Right, because y equals the square root of u. It's because I knew I had one to cancel with there. If I had called this y, I'd have to realize that was y too, and they still cancel because they're equal to each other. All right, I can factor that 2 out front, giving me a 1/6. And now I just have the indefinite integral of cosine y dy. Well, the antiderivative of cosine is sine plus c. Now I have to remember I'm not done. I have to go back through each of my substitutions to get back to the original variable. So y is the square root of u. All right, u is 3x squared plus 6. And then finally, x was equal to 2r minus 1. And there's our final answer, the antiderivative we were looking for. 1/6 sine of the square root of 3 times 2r minus 1 squared plus 6 plus c.